Baking and chemistry go hand in hand. Both chemistry and baking require precision in terms of timing and ingredient measurements, which then results in a myriad of chemical reactions. So let's start off by focusing on the various types of ingredients we use while baking. Here is a list of ingredients we will be discussing about: yeast, flour, sugar, along with the chemical reactions they participate in. Let's start off with yeast. Yeast is a single-celled organism that grows via budding. It requires warmth, an optimum temperature of 25 degrees Celsius to 30 degrees Celsius, moisture, and even food to grow. Hence, bakers can store their yeast for a short period of time in refrigerators to lower their growth rate. Their food could be in the form of starch and sugar. When baking, bakers should use lukewarm utensils and water to activate the yeast. Yeast takes part in an important reaction known as fermentation, or more specifically, ethanol fermentation. For breads, ethanol fermentation is necessary to let the bread dough rise and become a smooth, extensible dough with good gas-holding properties. Only ethanol fermentation takes place in the bread dough, as there is a limited oxygen supply, with which the yeast can only partially break down sugars. When it is added to the baking mixture, such as the dough or the batter, the yeast will feed on the sugar and form ethanol and carbon dioxide gas, as shown by this reaction. As such, sugar increases the rate of fermentation. This reaction is catalyzed by the presence of the yeast enzyme zymase. The enzyme in the yeast breaks down the starch present in the flour into sugars through the following process. First, using amylase to break down starch into maltose, then using maltase to break down maltose into glucose. The glucose obtained is food for the yeast that gives it energy to react and produce CO2 gas and ethanol. So, how exactly does yeast affect baking? A. The carbon dioxide gas bubbles would cause the bread to the batter to rise. B. The ethanol would kill the bacteria in the bread, making it safer to eat. C. The ethanol would lower the pH of the batter, similar to that of our digestive acids, making it easier to digest. The carbon dioxide gas bubble will cause the dough or the batter to rise or expand. The carbon dioxide bubbles would form around yeast stills. These bubbles will be, in turn, surrounded by gluten. These bubbles then cause the dough to increase in size and fill it with gas. Bakers can knead the dough thoroughly to distribute the bubbles of carbon dioxide gas and leave it to rise again if needed. However, bakers should note that the dough will turn sour if it is left too long. This is as the oxidation of alcohol will produce ethanoic acid. As such, the ethanoic acid produced turns the dough sour. Hence, bakers need to ensure that they do not leave their dough untouched too long. Usually, the ethanol produced will evaporate from the dough due to the heat in the oven. So, as we have already seen, yeast requires starch to start off with the chemical reactions. This starch actually comes from the flour. The flour we use in baking is especially important because it contains proteins, more specifically glutenins and gliadinins, which are large molecules made up of amino acids. These proteins play a major role in the viscosity of the dough system. The amino acids play an important role in Maillard reactions, which we'll be learning about very soon. But before we move on to that, let's just get an understanding of the reactions that the proteins take part in. When water is added to the flour, the proteins line up with each other. They form hydrogen bonds, ionic bonds, and disulfide cross-links between the chains of gliadinin and glutenin, leading up to the formation of the gluten network in the dough. Note here, gliadinin and glutenin bond to form gluten. Gluten is formed when gliadinin and glutenin, two water-insoluble proteins, are hydrated with water and forced to react. Bakers should knead their dough well so the proteins can uncoil and interact with each other to strengthen the gluten network. But how much should bakers knead the dough if they want their bread to be soft? A. Knead the dough till it becomes hard. B. Knead the dough once or twice. C. Don't knead the dough at all. If bakers want them to bake softer bread or cakes, they should knead the dough lesser, for they would want lesser gluten to form. If they want a chewy and a crispy product, kneading it more is the way to go. And for the last ingredient, but a major ingredient, sugar. While sugar is a sweetener, it is also used in Maillard reactions. It undergoes many chemical reactions at temperatures higher than 160 degrees Celsius, mostly with amino acids, called Maillard reactions. Maillard reactions are non-enzymatic reactions between reducing sugar, an amino acid that results in the browning of food and the flavor of certain foodstuffs. This reaction can also produce many different kinds of flavor compounds. Different types of amino acid result in the formation of different types of flour flavor compounds. Bakers should note that the specific type of compounds that are formed depends on the baking time and temperature, as well as the kind of sugars and amino acids that were added to the reaction. Maillard reactions begin at lower temperatures. During the Maillard reaction, the carbonyl group of sugar, which can either be aldehyde or ketone, reacts with the nucleophilic amino group present in the amino acid to produce water and N-substituted glycosylamine. By the way, aldehyde and ketones are carbonyl compounds, or compounds that contain a carbonyl group, a carbon-oxygen double bond. The N-substituted glycosamine then isomerizes and is rearranged to form ketosamine. The ketosamine then can react in a number of ways to produce meladonins, which are brown pigments and other flavor compounds. However, bakers should note that if they leave the reaction to occur at high temperatures for too long, acrylamide, a carcinogenic compound, will be formed as a result of these Maillard reactions. Hence, bakers should avoid burning their food. And that is all for today. Till next time, let your next chemistry practical be baking a bread. Thank you.